A common use of calculus is to find the minimum and maximum points in a function. For example, we might want to find out how many seconds it took for a kicked football to reach its maximum height, or how long it took for the application of some fertilizer to be effective in reversing the decline of flower growth. We've already seen that when a function changes direction to create a maximum peak or a minimum trough, the derivative of that function is zero. So a step towards finding these extreme points might be to simply find all the points in the function where the derivative is zero. So here's a very simple function that returns x squared, and here's the graph for that function. We can use the power rule to find the function's derivative. It's 2 times x to the power of 1, so 2x. Now the derivative is itself a function, so let's graph that as well, and we can see that the derivative slope is increasing at a constant rate as x increases. Now when the derivative is 0, we know we found a critical point. In this case, we need to find when 2x would return a value of 0, and that would be when x itself is 0. But without looking at the graph, how can we tell if it's a minimum, a maximum, or just an inflection point? Well, since the derivative is actually a function, it itself has a derivative that will tell us its slope. In other words, it will tell us the rate of change for the rate of change of the function. Now formally, we call the derivative of the function its prime derivative, and the derivative of the prime derivative is the second order derivative. And we could use the power rule to calculate that the derivative of 2x is just 2. Now if we add the second order derivative to the graph, we can see that it's a straight line, reflecting the fact that the slope of the prime derivative is constant. So of course the second order derivative for the critical point where x is 0 is 2, which of course is a positive number. And that tells us that the slope of the prime derivative at that point is positive. So it's crossing 0 from negative to positive, which tells us we found a minimum value for the function. To find what that value is, we just use the function to calculate the f of x value for our critical point, in this case 0. And that tells us the minimum value returned by the function when x is 0 is 0. Let's look at another example. This time the function returns negative x squared plus 1. The prime derivative is negative 2x, and the second order derivative is negative 2. There's a critical point where the prime derivative is 0, which once again happens when x is 0. And we know that the second order derivative is a negative value, so when the prime derivative crosses 0, it's decreasing from positive to negative, which tells us the critical point is a maximum. The value returned by the function at that point is negative x squared plus 1. So with an x value of 0, the function returns 1. So 1 is the maximum value for the function.